Okay, so let's start today's session. Today we are going to simulate the single phase full wave uncontrolled rectifier for the resistive load. We already discussed the circuit and operating principle in the previous class. So whatever we obtained or seen the waveform in the previous class, we tried to simulate here in MATLAB and obtain the same respective waveform. That means average output voltage, supply input voltage waveform, and voltage across the diode, average output current. Whatever waveform we have discussed in the previous class for the single phase full wave uncontrolled rectifier for the resistive load, we same things try to implement here with the help of MATLAB. Okay, so first of all, just share the screen and then we will continue our discussion. Okay. Okay, fine. So first of all, just to open the MATLAB. Okay. Just wait few minutes. It takes some times. It takes some time for open the MATLAB. Okay, before that, you have to keep in your mind what are the components required for simulate the single phase full wave uncontrolled rectifier for the resistive load. Okay, so you maybe observe from that requirement with the help of circuit diagram, whatever we discussed in the previous class. So just you maybe recall what types of component we required. That means for simulate the single phase half wave, single phase full wave bridge type uncontrolled rectifier for the resistive load. So first of all, just wait few minutes. So first open the MATLAB and then we will simulate the circuit. It takes some time for open the MATLAB. Just wait few more minutes. Yeah. Okay. So this is the interface of the MATLAB. Here we require to simulate the single phase full wave bridge type uncontrolled rectifier. Okay. So we already familiar with the MATLAB. Just try to write here Simulink and press enter here Simulink. And press enter here. Okay. So now we just try to open new workspace here. So where we required to simulate the circuit. So first of all, go to this one, new, and click here and just Simulink model. Okay. So create new workspace. So it takes some time for create new workspace. Just wait few more minutes. So it takes some time for open the new workspace. Okay, so now it's open the new workspace with the title of unleashed title here. Okay, so you maybe save this file in the folder. So just click here and save as. So just I want to save in a folder here. That means in simulation lab. Okay. So we already modeled some simulation model. So just name it another model here. That means model number 17. Model 17 and save. So this folder is name with model number 17. Okay. So now you may observe that this untitled folder file just name as the model number 17 and save in the folder of 6th semester simulation lab. Okay. So now you can simulate the single page full wave and control rectifier for this type rectifier for the resistive load. So you have to remember what components we require for design this circuit. So whatever the component required, that means we go for the simulation library and just drag to that component in new workspace. Okay, so just this is your Simulink library. Just here you maybe search as some like a sync. That means we required here a scope. Okay, where we can observe the waveform, various type of waveform. That means single page AC source, voltage source, and output voltage waveform, output current, and voltage across the diode. So just click on that one and just drag to the model number 17 scope. Okay, what we another component required for simulate the circuit? Single page AC source. Is not single page AC source, 4 number of diodes, one resistive load, and measuring device. That means voltmeter and current emitter for the measurement of current or observation of current waveform and voltage waveform. Okay, so go to the sorry, seam cap. Let's go for the in seam cap, and in seam cap you just go for the seam power system. Here you maybe find the seam power system. Okay. So in SIM power system, you will find out various type of block assembled here in just like as a electrical source, element, machine, measurement, power electronics. So we required electrical source, that is single phase AC voltage source. You not. So just we drag from this point, that means single phase AC voltage source. So just various type of electrical source available here. That means AC current source, single phase voltage AC source, control current source, battery, control voltage source, and DC voltage source, whatever. So three phase source. So according to your requirement of voltage source, you may be select from here to the model number 17. So just add and drag to the model number 17. Okay. Now, what we next required, that means power electronics switching devices. That means what we have used here, diode. Okay. So just various type of power electronic switching device is available here. You may be used according to your requirement. So diode here. Now we just add to the model number 17. Diode here. And next, what we required, resistive load. So go to the element you may find out various type of electrical element here. So we just go series RLC branch. So just add to the model number 17. And next we required measuring element. So just to go to the measurement. So various type of measuring instrument available here for the measurement of current emitter is given here, measurement of voltmeter, voltmeter is given here. So we required for voltmeter. So just add to the model number 17, and for measurement of current, add to the model number 17. Okay. So also you may be observe impedance measurement, multimeter, okay, 3-phase VI measurement. So next what we required, that means one power guy for the operation of power system, in power system. So power guy. So just type here and search. So now whatever here, so just add to model number 17. Now we just resemble the component as the circuit uh, and rearrange. So just first of all, full screen this one, and just simulate. So just power guy put here. Now this voltmeter is tagged to this point. Okay, voltmeter, and this is your load, and this is your diode, and this is your AC voltage source, and this is your scope. Okay, so just click on the continuous power guy. And configuration parameters. Just change this one, that means discrete, and sample time takes by default value 50 microsecond. So apply and OK. And this one, okay. Okay. Now you just arrange all the component in a proper manner for single phase full wave uncontrolled rectifier. So as you know that through the help of circuit diagram you required 4 number of diodes, is not. So just you maybe create another 3 diodes from this one by clicking here and drag to another point. So diode number 2, diode number 3, diode number 4. Okay. So this one you maybe eliminate and just clear this one. Forward voltage drop is almost 0, and this one, so measurement part, apply and okay. Okay, so again same things, I repeat for all the diodes. Forward voltage drop, we for the ideal diode we just consider as a 0 voltage drop, and just measurement part, so just apply and okay. And this one again for 0. Measurement part, just enable this one and apply and okay. Okay, so here is restrict diode number 4. Okay, so just click on just 0 and just enable this one and apply and okay. Okay, apply and okay. Now just arrange this diode in a proper sequence. So whatever we discuss in the circuit diagram. So just to display this one here. So diode number 1 and 3 in upper portion. So just drag in proper manner. Diode number 3, diode number 4. Okay. So just rotate this one by Control R. Okay. And this one also rotate. Control R. And just move slightly upward direction for the proper sequence. And this one is your diode number 2. Just place here and rotate. Okay. Here. Now you just connect this diode 1 and 2. This one is your 3. So just connect from this point to this point. So just move slightly here. Now from this point to this point, you have to connect. And from this point to this point, you have to connect. And you have to connect this point to this point. And now this AC voltage source just connected from this point to this point, and this point to this point. You will be right here A and B. So this is your A and this is your B. Now you just connect this load that will be required pure resistive. So just click on this one, and according to your requirement of the load, you just click here. You may be select corresponding what is your requirement, pure resistive, inductive, capacitive, RL, RC, LC. Okay. So our requirement is pure resistive. So just click on the resistance, and just you put here any value of the resistance. That means suppose that if you put 10 ohm. Okay. So apply and okay. So this one becomes resistive load. So just Control R, just put here and just connect from this point to this point. If you want to measure the output current to waveform, then just connect from this emitter at this point to this point, and from this point to this point. Okay. Next is your this point to this point. Okay. So now it will be connected in proper manner. Is it not? So just yeah. Now you may be required another type of voltmeter for the measurement of input power of voltage waveform and output voltage form. So one more voltmeter you required. So just create from here another voltmeter. So this one move up to this point, and this voltmeter you may be connected such like just if you rotate this one. Okay. So just to go to this point, from this point to this point, and this point to this point. Okay. And this voltmeter you will be connected across the output of the rectifier. So you will connect here and connect here. Okay. Now just create here number of axes more because we required one more voltmeter if you want to voltage across the diode D1 and D2. So we just try to observe that voltage across the diode 1 and diode 2. So we just create another voltmeter. That means suppose that here to connect it this diode at this point to this point. Okay. So this is voltage voltmeter connected across diode 1 and diode 2. So just increase the number of axes of the here scope. So just click on scope and increase the number of axes. So we required 4 number of axes. So just put here 4, apply and okay. So 4 number of axes created here. Now we just click on the AC supply voltage, that means peak amplitude. Okay. So what is the peak amplitude for the single phase? If you consider 220 volt RMS value, 230 volt, then just multiply by root 2, then you will get the value of maximum voltage. Okay. So 230 into 1.41 equal to 224. Okay. So 324 is value 324. So just put here 324. Frequency is your 50 hertz. So just put here 50 hertz. Okay. Apply. And just for simplicity, here maybe put 325 or 224, whatever you want to put. So now you just connect the output of the voltmeter of across the supply voltage and output voltage voltmeter and voltage across the diode 1 and 2. Then we will connect another diode for the diode number 3 and 4. So just increase size of this scope. So just connect here from this point. So maybe here. Yeah. Okay. So this one connected. Supply input voltage waveform across terminal 1. Supply output voltage across terminal 2. Output current. You may connect to this one. Just connect to this one. Part 3. And this one. So part 1. Yeah. So I think this is connected according to the circuit diagram. Okay. Now we just run this model and just try to see 0.03. So now just run the model. Now compiling this one. Okay. And next is just to click on the scope. You are able to increase the size, and this one is your auto scale. Okay, so this is your supply input voltage waveform, that is maximum value is your how much? 324, is it not? 324. So complete one cycle from this point to this point, and again this positive half cycle up to this point. Okay, so this is your supply input voltage waveform. This is your supply input voltage waveform, and corresponding to that, this one is your output voltage waveform. You maybe observe that from 0 to pi, you will get the positive half cycle output voltage, whatever the input voltage waveform that is follow here, same things. Okay, so you may be obtained the voltage waveform from this point to this point is same as the input supply voltage, that means 0 to pi, and from again 0 to pi to 2 pi when the diode D3 and D4 conduct. So again you will get the output voltage as same as the previous one, that means 324. Okay, and this is your output current for the resistive load. So whatever the waveform for the voltage that will follow by the current also, that means similar waveform. So this is the waveform from 0 to pi for the output average output current is same as the output voltage waveform repeated here. I think we already same things. Now we just so it is first three waveform, that means this one, and this one is your supply input voltage waveform, output voltage waveform, and input voltage waveform. Okay. Now we just concern about the connection of the voltage across the diode 1 and 2. So voltage across the diode 1 and 2, that means when it is in forward bias, that means conducted, so it will be maybe I think so in reverse one, because whenever the diode in forward bias and conduct, so voltage across the diode D1 and D2 becomes 0. So this connection we require to check out in this simulation part, and it will be giving the when the reverse bias, that means no conduction, so output voltage is output voltage conduction showing the at this point. So this one is reverse ones. So just we try to check this is not the proper voltage waveform of the diode 1 and 2. It will be just check out the connection. So just this one voltage across the diode D1 and D2. So here required and the conduction take place, that means voltage across the diode 1 and 2 in the positive half cycle, it becomes 0 homogeneous. Okay, so connection of this voltmeter, that means fourth, is required not in proper manner. So if we connect this diode, then in forward bias, that means diode is protecting one. So if you connect this one, this and this also becomes short circuit now. So we just try to connect from this point to this point. Okay. Now you just check out what is the voltage waveform. So first of all, just run the model. Now just click on this one. Okay. I think the voltage across the diode 1 and 2 is not showing proper. So just we try to check out this one. Okay. So you may be obtain that the whatever the voltage maximum value, okay, 324. So you will get the value of maximum output current. That means 32.4, because the resistance value you have already taken 10. So 324 divided by 10 equal to how much? 32.4. So you maybe obtain that means maximum value is your 32.4. But still we have to check out the connection of the voltmeter across the diode 1 and 2. Because whenever the diode 1 and 2 in forward bias, that means in conduction mode, so voltage from 0 to pi becomes 0. But here showing is a voltage of the same. That means we have to check out the connection of the voltage across the diode D1 and D2. Okay, so just check out how we can connect this diode. If you want to voltmeter voltage across the diode 1 and 2, during the conduction period. So if we add this voltage VAB, this one to this one, sorted. The connection is not in the proper manner for the diode 1 and 2. So we took the connection of diode 1 and 2 in the forward bias mode. That means becomes 0. Okay. And in the reverse bias mode, this one maybe connect at this point. Heavy, that means output voltage is positive half cycle. Just connect voltmeter at this point. So now if you want to connect one display here, that means what is the measurement value? So we required one display. That one just wait here. So again, just go to the Simulink library and go for sync. That means display. Okay. So if you want to add here, that means the display. So if you want to connect here, that means showing the value of this display, showing to you numerical value of the current. And similarly, if you connect another display at this point, okay, then you will get showing the value of output voltage. Okay. Now just run the model. Okay, so these three waveforms are very accurate. Whatever we explained in the previous class, that means input voltage waveform, output voltage waveform, and output current waveform. Okay, so that numerical value you may, this is your waveform variation, and showing their numerical value. So this display. So I think it is also not showing the proper value. Okay, it's not showing the proper numerical value because we have the average. What is the value of average output current? Average output current, measurement of average output current. That means 324 is your maximum voltage. Okay, and what is the value of average output voltage, that means 2 pm by 2 vm by pi. We thought what we have derived few minutes earlier. Okay, so you maybe compare this circuit waveform, or you maybe change their resistance value or supply input voltage. Suppose that if you change the value at this point, so we want to measure the voltage waveform across the diode 1 and 2. So how we can connect voltmeter across diode 1 and 2 during the positive half cycle, so it will become 0. That means if you want to connect one voltmeter at this point, to this point the output voltage is superior. Voltage versus that one. That means if you want to connect, so this is not showing proper value, so we can just take out this one. Okay, and just connect another voltmeter for that voltage across diode 1 and 2. So how we can connect voltage across diode 1 and 2? That means we want to connect. Suppose that in such a way that something like at this point, we need to do at conduction mode. So now we just connect from this point to this point. Okay. So voltage across this diode is positive half cycle. So just run this model and just click on the scope. So just go for auto scale. Yeah, so this is the voltage across the diode when the diode 1 in forward bias, that means in conduction mode. So voltage across this diode becomes 0. Okay, and in the negative half cycle, you have to just obtain the negative waveform. Okay, that means in the negative half cycle, that means this waveform up to this waveform. But again, it will be showing for the reverse polarity. That means we have to connect another voltmeter. That means voltage across the diode. Okay. So this is all about the voltage waveform, current waveform of the single phase full wave uncontrolled rectifier. Okay. So we can practice such type of simulation circuit in MATLAB. So we are more familiar and we can observe their waveform of various power electronic circuit. Okay. So you have to just more and more practice required for simulate any circuit in MATLAB. Okay. So you practice by own whenever you got the free times in the MATLAB. Okay, fine. So just we stop here, and in the next class we will discuss another things. So just this is all about of the single phase full wave uncontrolled rectifier output input voltage waveform, output voltage waveform, and output current waveform. Okay, according to the circuit we have designed in the MATLAB. So this is similar to the waveform what we were discussed in the previous class. Okay, so just we stop here. Next class. So in this way, you maybe practice some simulation circuit in the MATLAB. So just we stop here.